Hi guys, so today we are going to be talking about line and curve of best fit. So this is something we did not talk about back when we did quadratics and whatnot, so we're going to talk about it today. Basically what you're going to do is we are going to input data into a table and have Desmos do the hard work for us and tell us what's called the line of best fit. In other words, that means it's going to calculate the equation of the line for you. So we're going to use this data on the first table on our notes page. This is kind of a how-to guide on how to use tables. So you definitely want to have Desmos open so that way you can follow along. Make sure you're using the Desmos Virginia graphing calculator. All right, so we're going to press the plus button over here on the side, and we're going to add a table. Now you'll notice I do have a couple extra features just because the iPad version of Desmos is not the Virginia version, but the ones that you see here in the pictures are going to be just right. All right, so we're going to start with our table. Make sure every time you do one of these questions, you always start with a cleared calculator because you want it to come up with x1 and y1 at the top. If you don't clear your calculator, it's going to come up with x2 or maybe even x3 if you've already created a table before. So make sure you clear your calculator every time. We're going to input the data points that it gives us in the table. So it said 2, 7, and 4. And then we're going to plug in 3, 5, and 3. All right, so you'll see that it graphs those 3 dots out in space. We don't know what the relationship between those dots are. That's what we're going to do. What we're going to do is we are going to find a line of best fit and a curve of best fit. Let's focus on the line of best fit first. So you'll notice this formula looks very similar to your slope-intercept form. The big difference here is that we use what's called a tilde. That's that squiggly line, excuse my alarm there, that squiggly line instead of an equal sign. So we're going to go to a new line here. We're going to go to a new line, and we're going to type in that equation. We're just going to press y1. You don't have to do anything special, just type in a number 1. Then we're going to use the little tilde symbol. You can use it on your keyboard, or it is in the keyboard that comes up on Desmos. We're going to type in mx1. Again, it's going to bop that little 1 down. And then we're going to write plus b. And what you'll notice is it's going to graph a straight line through all of your data points. What we can do with that straight line is you'll see it gives us something called parameters. Like it says here, we're not worried about the statistics. We're not worried about that thing that says residuals. Ignore all that. But we're looking down there at parameters. And what we can see is it's telling us a slope. It's going to give us a decimal for a slope, and it's going to give us a decimal for your y-intercept. Now, I know these are yucky decimals, so we're just going to round them to 2 decimal points. And we can put them together to make an equation of the line. So that line is represented by y equals 0.42x plus 1.84. That would be your y-intercept. We can also do a curve of best fit. So you'll notice that's just like the standard form of a quadratic equation. Again, we type in y1. We use that little tilde symbol instead of the equal sign. A. Now here's where it's important. You must use those parentheses. It's going to mess up your answer otherwise. So x1, close your parentheses, squared, plus bx. Again, you need that 1 plus c. We're going to type it in exactly the way that it's written. That is not given to you on your formula sheet. However, it is very similar to the quadratic standard form, so hopefully you can remember it. All right, so then when we get down into all of the data that comes out of this, we can see there's an A, B, and a C. We can plug those guys in, A, B, and C, and we can get our standard form of the equation. Again, we're going to round to 2 decimal points. The only one we don't need to round to 2 decimal points would be B, that's already rounded at 1 decimal point. So that would be y equals 0.13x squared minus 0.8x plus 4.07. That's how we use Desmos. Now let's see how we're going to use this in the questions, okay? This page is your hints and notes. It just didn't fit over here on the side. That's why it's off to the side. We've got a new question here, so I'm going to go to settings. I'm going to delete all, and I'm going to clear my calculator and reset us. We're going to start by adding a table, and we're going to add this table in that they gave us. So it says 0, 3, 5, 8, and it's going to try and guess what data points you want to put in there, so don't worry if it does guess some points incorrectly. We're going to put in 5, 4, 3.2, and 2.9. That's the exact table it gave me. You can see that it graphed those ordered pairs up there at the top. When we read the question, it says Bill rode his bike to the store from his house. The table shows the distance from the store paired with the number of minutes after leaving his house. Find the line of best fit. You see where it says line of best fit? That means we are going to be using the line formula, not the curve formula. You can also see down here in your in your options that all of those options are lines of best fit. So we're going to follow that formula down there at the bottom, and we're going to put in y1. That's referencing this table where it says y1. We're going to put in a tilde. That's that little squiggle line. mx1, forgot the m there. mx1 plus b at the end. It's going to give us those parameters of negative 0.27, that would round to 0.3, and then 4.857, that would round to 4.9. So that would be letter choice C. All right, looking at problem number 2. Again, we're going to draw the line of best fit in here, just that way you can see what the calculator is doing. We're going to draw a line in here, and it's just putting a line through as many points as possible. You're best fitting the line. So again, we're going to make an estimate here of where we think the line would go. Looking at those equations, you see the two that have a intercept of -4. Our graph doesn't even show y is negative, so we're going to get rid of letter choice C and D right off the bat. Now, did my line cross at 5 or did my line cross at 6? So let's see. Excuse me. I'm going to try my slope here, and it's going to go up 1 and then over 2. It's going to go up 1 and over 1. So I think the better fit here, because again, this is not a perfect line. Oops. This is not a perfect line. We crossed here at about, I would say that the slope is closer to 1. Yeah, the slope is closer to 1 than 2, so we're going to go with letter choice B. Again, this is a best fit line, so you're going to have to make the guess on what makes the most sense. That line is definitely not steep enough to go up 2 each time, so I'm going to go with letter choice B. All right, looking at number 3. Again, this one's going to have you go ahead and put it in the table. I'm going to go ahead and have you do this one by yourself. All right, looking at problem number 4, again, we're going to go ahead and clear our calculator every time. That way we always start with a fresh calculator. Debbie recorded the time it took 7 children of different ages to run 1 lap around the track. We're going to go ahead and put in Debbie's table here. We've got 4, 8, 10, 11, 14, 14, and 18. We can go ahead and put in those datas, 225. You can type this in on your own so you can follow along. All right, so we've got that line of best fit. It says using a linear equation of best fit. That means, again, that line of best fit. So we're going to use that y equals 1, and we're going to type it in y tilde mx, I forgot the 1 on the y there, so we'll go back and add it. y1 mx1 plus b. Ta-da, there he is. If you don't see the dots, you can always zoom out. There we go, and we can see those dots much farther up. That's because our data was so big, we had to zoom out to see it. All right, so what the question asks is, which is the closest to the length of time it would take a 6-year-old to run 1 lap? So we're going to zoom back in just a little bit here. Trying to make this so we can actually see it. There we go. All right, so I'm looking for a data point at 6 years old. So you'll see that one is an 18-year-old. We're looking for a 6-year-old. So I can follow this line up until I get data points around 6 years old. So that one's 8, that one's 4. So we're going to tap on the black line, and we're going to look for it to be about 6. So I'm just dragging my mouse right over the line. So you'll see when I get to 6, it's close to 200. So we're going to look at which of these answer choices is closest to 200. So let's go back one more time. So when I look at 6, it's going to be right there. I think it says 199.5. So the closest, the best answer choice would be 200 even. So that's going to be letter choice B, 200 seconds. Go ahead and try question 5 by yourself. All right, so question number 7, or is this 6? This is 6. Says that we've got the state of California tracking how many third grade students are score proficient or higher on their CST. It's kind of like our SOL tests. So they're going to tell us that x equals 6 represents the year 2006, just so that way your graph isn't huge. So we're going to change each of those years to just 6, 7, 8, 9, and 10. Make it a little easier. They want us to find the equation of the curve of best fit. Notice how that one says curve of best fit. That means this time we are going to use the other equations. We're going to go ahead and clear our calculator because we always clear it. We're going to add our table. Their table is sideways, but that's okay. We can still add ours. We're going to do 6, 7, 8, 9, and 10. Remember, we're just cutting off the 2000 part to make your graph a little easier to read. Now we're going to type in those percents: 36%, 37%, 38%, 44%, and 44%. We still need to zoom out just a little so we can see our data there. There he is. And we're going to go ahead and put in our curve of best fit. So our curve of best fit is y1 tilde a parentheses x1 squared plus bx1 plus c. Don't forget, my friends, you have to have those parentheses around the x1, otherwise it's going to mess up your answer. All right, so now we've got our equation. There are our 3 letters. I'm not going to write it in the box because that box is very small. So it's going to look like this. It's going to be y equals, and we're going to, I don't know why it says function notation. You can ignore that part. We're going to say y equals our a value of 0.21 x squared. Our b value is minus 1.13x plus 34.69. And that would be our equation for the curve of best fit. All right, so number 7, using that equation you found above, predict the percentage of California third grade students who will score proficient or higher in 2013. So we're looking for a value at 13. So we're going to follow the line. Again, we tap on that line. We're looking for a value of 13. I might have to zoom out just a little bit more. There we go. We're looking for our value of 13. Ah, there it is. Right there at 13. We see it's going to be right about 56.2, somewhere around that. So our best prediction would be about 56%. Okay? Go ahead and try question number 8. I know it says function notation, but you don't need to do function notation. You can just give me the equation for the curve of best fit. And I'm going to go ahead and have you do question 9 by yourself as well. Make sure you fill in your skills checklist and you can get started on your homework. I hope today was easy for you guys. If you have any questions, please feel free to reach out.